Algebra I 10.11c, we have a theorem and proof for multiplying two rational numbers. It says for any rational numbers, a or c, and any non-zero rational numbers, b or d, we can do a divided by b times c divided by d. See? Fractions are little division problems. So we can actually just put the a and c together over the b and d. That's what this theorem says. It would almost be like we had 2/3 times 4/5. So we just say 2 times 4 over 3 times 5. That's all. Just remember, a theorem is a property that can be proved by using axioms, definitions, and other theorems. We covered that back in Chapter 2 in the beginning of Algebra 1. All right? I'll have a link to that if you want. We can use the division theorem and the reciprocal theorem. We talked about that in the previous two videos. We can use them with the associative and commutative properties and the transitive properties to prove the theorem for multiplying rational numbers. So we can use the division theorem, the reciprocal theorem that we just covered, along with the associative, commutative, and transitive properties to prove this in a proof table. So just remember what we covered, and I'll have links to these in the description of this video. The division theorem, which was video number 10.11a, it said that if you're dividing a by b, that you could just do a times 1 over b, as long as b is not a 0. And the reciprocal theorem was the video right after that, right before this one, and it said if you're dividing 1 by ab, it's the same thing as doing 1 over a times 1 over b, as long as b is not a 0, all right? If you haven't seen those videos, you definitely need to go into the description and click on those links so you understand. So here's a proof table. And a proof table is used in geometry, which you're going to do next year after Algebra 1. And it teaches you logical thinking and step-by-step logical thinking. So in a proof table, you've got statements on this side and reasons on this side. And for every statement you make, you give your reason. Okay? So our statement is, if we have a over b, and it's equal to a times 1 over b, and c over d is equal to c times 1 over d, that is the division theorem. That says that we can divide by multiplying by the reciprocal of the denominator. Our second statement is a over b times c over d is the same thing as a times 1 over b, like that one, times c times 1 over d, like that one. And we're just substituting the 1 times 1 over, the a times 1 over b for the a over b. See, we're substituting these for each other, and then we're going to substitute these for each other. So now this equation looks like this. And this equals this. By using the associative and commutative property, the associative property says that we can regroup, and the commutative property says we can put them in a different order. This a and c can be grouped together, and this 1 over b and 1 over d can be grouped together. And a times c over 1, or ac, times 1 over bd. See how it would just be ac over bd like that? That's the reciprocal theorem. That's what we did in 10.11b. That's the reciprocal of the product is the product of the reciprocal. Now we've got a times c over bd. That's the division theorem again. And it basically just means a over b times c over d, doesn't it? It's the same thing. And if this is the same thing as this, then this is the same thing as this, and we've proven it. That was the transitive property. Transitive property says if a equals b and b equals c, then a equals c. We did that back in video 2.10b. So basically, making a proof table is like the transitive property. You go from a to c by connecting first a to the b, then b to the c, and you prove the connection from a to c. If a equals b equals c, then a equals c, right? If you look at this proof table, we've got this right here, number 2, equals number 3, which equals number 4, which equals number 5. Well, if all of these equal each other, then that means that this number 2 equals number 5. See? If you have a straight line of something equals something equals something, then the end ones equal each other. See? These all equal each other, so this equals this. See? So that's our proof table. And you're going to be doing a lot of that in geometry, okay, with a lot of theorems and axioms and postulates and definitions. Our next video, 11.1a, we're going to do a rational expression word problem where we're going to use the strategy of working backwards to solve it, all right? And if you want to see all the previous videos for Chapter 10 and the reciprocal theorem and proof we did, or the division theorem and proof we did, which might be a good idea, we also covered the factor theorem. We didn't do a proof for it, but we covered what it means. Then my algebra word problem playlist will be in there, and the video on what is a theorem will be in there, okay? So check the description. And don't forget, I'm on patreon.com if you'd like to become a regular monthly patron, or you can just go to my YouTube channel homepage for JoAnn School, and you can click the support button, and you can support me with a one-time donation, and that'll help Bitsy, Lola, and me survive month to month. I hope this was helpful, and I'll see you next video. Bye.